ACCA, Developing Professional Accountants.
We're now going to look at the most popular exam forecasting question. This is where we look at something called learning curve. Now, all learning curve focuses on is the relationship between the time taken by labour and the cumulative production. The idea being that the more units of the same product that you produce, the less time that you need each and every unit, because of course you learn how to do it. Now, the relationship that we have here is very simple, but you have to fully understand it. Now, what I've got here is I've written down precisely what that relationship states. As cumulative production doubles, so as the production units double from 1 to 2, from 2 to 4, from 4 to 8, and so on, from the first unit, the cumulative average time per unit falls by a constant percentage. So, every time we have a doubling of production, the average time per unit falls. Now, the important thing to remember about learning curve is the way that it works. Now, it's stated here, but just to try and describe it a little bit more clearly, everything relates to the first unit. We can calculate, say, the time taken for the first 4 units or the first 8 units. But what happens if I want to calculate the time taken, say, for the 8th and final unit? Well, the only way we can do that is by calculating the total time for 8 units minus the total time for 7 units. That is the only way. So remember, everything relates to the first units and cumulative production. I will repeat that point. If we were to look at the relationship of learning curve, we would see something a bit like this, if it were expressed as a graph. One thing I'd like to point out to you is that at some point, the learning effect will stop. At that point, we would describe production as being at steady state. Remember what I said a moment ago. The only way that we can establish the time taken for an individual unit is to establish the total units up to that point minus the total units one before that point. So, for example, if steady state production were to occur at 100 units, to establish the time taken for all of those units subsequently, the only way we could do this is to calculate the total time taken for 100 units minus the total time taken by 99 units, and that would give us the time taken for the 100th unit. And of course, that would be the same time for every subsequent unit thereafter. Now, looking at this graph, anything that we can describe in the form of a graph, we can also describe in the form of a formula. And luckily, your examiner gives you the formula and tells you what every component is. So, we have a formula here of y equals ax to the b. Very straightforward, where a is the time taken for the first unit. You could say cost, but I always work in time myself. X is the cumulative production or output, and B is the learning curve coefficient, which is the log of the rate over the log of 2. So we'll see how this works in a moment, okay? But before we do that, what I want to do is to go back to a simpler analysis that illustrates learning curve. I do this for 2 reasons. One is to gain an understanding, but maybe more importantly, whenever learning curve comes up, the examiner often looks for simple relationships that you could do just with a simple numerical example. So we have an example. If the first unit required takes 100 hours and the learning curve rate is 80%, calculate the following cumulative and incremental data. Well, okay, I said to you that the way that this works is cumulatively. So let's just look at that first of all. Once we've done all that, then we will look at the incremental analysis. Okay? Because this is what I want you to do in any exam question. I want you to focus on the cumulative data, which is all about learning curve, first of all. And once you've got that sorted, applying it to the question is going to be very easy. So, we've got our cumulative units. 1 to 2 to 4 to 8. In simple terms, we're simply multiplying by 2 each time. We're doubling. Okay? And we said that the average time for the first unit was 100 hours. Because the learning curve rate is 80%, all we want to do is say, well, look, as cumulative production doubles, cumulative time falls by a constant percentage. So, we take 80% of 100, that gives us 80. We take 80% of 80, that gives us 64. And we take 80% of 64, and that gives us 51.2. Now remember what these numbers mean. When I give you, say, 64, what I am saying is that the average time of all of the first 4 units, 1, 2, 3 and 4, take 64. So in total terms, the first unit has taken 100 hours. The first 2 units, 2 multiplied by 80, 160. The first 4 units, 256. And the first 8 units, 409.6. Okay? That is how learning curve works. As cumulative production doubles, the cumulative average time per unit falls by a constant percentage, in this case, 80%. So now what we want to do is to look at the incremental time. So, we have 1 unit, the total time is 100, so the average time is 100. Not very difficult there, I hope. Moving from 1 to 2 units, we have 1 additional unit. The additional time taken is the difference between 160 and 100, and that's 60. So the average time is 60. Moving from 2 to 4 units, we have an incremental 2 units. The incremental time is the difference between 256 and 160, 96. So the average time per unit is 48. Now, remember how learning curve works. Every time we produce a unit, there will be a learning effect. So what we're seeing there is that the average time for each of those 2 units is 48 hours, but we would expect the 3rd unit to take slightly more time and the 4th unit to take slightly less time. Okay? Every single unit there is a learning effect. And we have 4 units, incremental time of 153.6, and that means it takes 38.4 hours on average. Now, this sort of computation is often asked for in the exam, just for a couple of marks, just to illustrate understanding. But the problem with doing this sort of working is that it only works if we're looking at doubles, 1, 2, 4, 8. It doesn't give us any understanding of the time taken for 7 units or 5 units or anything of that nature. So now we've got that basic understanding. What I want to do is I want to go away and look at the formula and see how the formula may work. So let's look at the formula more closely now. And the first thing I want to do is I want to look at B, the slope. It's the log of the learning curve rate over the log of 2. Let's see how this works. We said that B is the log of R over the log of 2. So let's just have a couple of rates here. The classic rates that you get in exam questions, they don't have to be this at all, but they tend to be 80% or 90%, okay? Now, given that we have that, what I want to do is to establish the value for B. So what I want to do is to find the log function on my calculator, the log of 0.8 over the log of 2. Now, I don't know if you remember from good old maths that a log of anything less than 1 will be negative. and therefore we're going to have something negative divided by something positive, and that will end up negative. What we end up with here is minus 0.3219. And if we did the same for 90%, the log of 0.9 over the log of 2, we end up with minus 0.152. Just to make you aware, in recent exams you have been given these rates, but there is no reason why you should be. So we have to be ready to calculate them. Check that you can use your calculator and get those numbers. Now what we want to do is we want to go back to the original example we had and just use the formula to prove that it calculates the numbers that it should calculate. I know you guys don't trust me. So if you remember, we said that A equals 100 hours. X is going to equal 2 and 3 and 4. I just want to prove the numbers that we've already got. And B, well, we said it was an 80% learning rate, so it's going to be minus 0.3219. Well, okay, given that we have those values, let's just look at how it works. If X equals 2, Y equals 100 multiplied by 2 to the power minus 0.3219. Pop that in the calculator and you get the value 80. Now what does that mean? Well, remember, the value is the average time per unit. So you get that first of all, and then if we want the time taken for the second unit, the only way we can do this is say 2 units are going to require 2 times the figure we've just calculated. 1 unit required 100 hours. Therefore, the time taken for the second unit is 60. Now, okay, these are very simple numbers. But what I'm trying to show you is the way that you approach any learning curve issue. Firstly, you establish the value from the formula. And only once you've got that value do you then think about interpreting what the examiner wants. This is the approach that we always use, and if we do this, we will have no problem in the question. Okay, X equals 3. Y equals 100 multiplied by 3 to the power minus 0.3219. What does that come to? It comes to 70.21. So we've established the average time taken for the first 3 units. If we want the time taken for the third unit, all we're going to say is that 3 units take 3 times the figure we have above, 210.63. 2 units we established before took 160 hours, therefore 50.63 hours is the amount of time for the third unit. One more step, we'll just check something. If X equals 4, Y equals 100 multiplied by 4 to the power minus 0.3219. If we multiply through, we get 64. I think we knew that number already from what we did before. Remember, we're just proving those numbers. And therefore, so looking at the fourth unit, we can establish that 4 units will take 4 times 64, and we said that was 256. 3 units we said would take 210.63, and therefore the fourth unit takes 45.37. hours. Interesting point whilst we're here. Remember, with the previous analysis, all we had was the average time for the third and the fourth unit. If we look at the numbers that we've got here, if we sum these two values here, this will come to 96 hours, which is the value that we calculated earlier. Okay, what I want to do now is to just play with numbers for a couple of minutes to make sure that we're absolutely confident with what we're doing. So let's just make up some numbers. If I say to you that A equals 50 hours, so that's the time taken for the first unit. And what I want here is I've got a learning curve rate of 90%. And if you remember, I said to you that that would have a learning curve coefficient of minus 0.152. So, if you wish, R equals 90%. So I've given you the two critical pieces of information. Now, once I've got those two critical pieces of information, then what I want to do is this. I want the time taken for the first 50 units. The second 50 units. If you wish, the first 50 units will be units 1 to 50, and the second 50 units will be from unit 51 to 100, just to make it absolutely clear. And the time taken for the 100th unit. Now, all I want to establish first of all is, given that I'm looking for these three pieces of information, what values of x do we need? Well, okay. I think we can all agree that we need x equals 50, okay? If for no other reason, to calculate 1. X equals 50. But remember how learning curve works. If we're looking at the time taken for the second 50 units, the only way we can do that is to establish total time for 100 units, you know, at the end of cumulative production, minus total time for 50 units, you know, cumulative time to the beginning of those 50 units of production. So what we will need is we'll need x equals 100 as well. The other thing we'll need is this. If we want the time taken for the 100th unit, if you remember what we said before, we need the time taken for 100 units minus the time taken for 99 units. If we do that, we'll get the time taken for 100. So those are the values of x. Now, once we've got that, remember what I said. The way we want to do this is, first of all, just get the values of x. You know, apply the learning curve. And once we've applied the learning curve, only then do we think about precisely how we're going to present the answer. So, x equals 50, x equals 100, and x equals 99. Y will equal 50, that's the value for A, of course, multiplied by 50 to the power minus 0.152. Y equals 50, multiplied by 100 to the power minus 0.152. And Y equals 50, multiplied by 99 to the power 0.152. If we get these out of the way, then we'll have no problem interpreting them. So we have the values. Now, the first thing we'll notice is that I've taken these values to 3 decimal places. Now, I think that that's really rather important, because there are certain circumstances where if you round too much to begin with, your answer will become wildly different to maybe what the examiner's answer will be. So let's think about more accuracy rather than less accuracy when we look at dealing with these questions. Well, okay, we've got these numbers. Now let's see how the numbers work. We've got to go and answer the question. Okay? Now the first question was what? The time taken for the first 50 units. Now that shouldn't be too difficult. So if we're looking at the first 50 units, all we're saying is that we had 27.588 hours per unit on average, and there were 50 of them. Very straightforward. If we were looking at the second 50 units, what we have to say is that we've got the time taken for 100 units, or at least we can calculate it. We know that each unit takes 24.830 hours, and there are 100 of them. We also know the time taken for 50 units. We've calculated it above. If we take one away from the other, we will establish the correct answer. And finally, we want the time taken for the 100th unit. And the way we're going to establish the time taken for the 100th unit is to look at the time taken by 100 units minus the time taken by 99 units. We already have the value for the time taken for 100 units, but if we look at the 99 units, we know that each unit takes 24.868 hours, and there are 99 of them. So, that is the way we would go about it. Let's bring them all into closer focus. So we have a value here of 1379.4 hours. If we're looking at the time taken for the second 50 units, we can say that 100 units takes 2483 hours minus the time taken for 50 units of 1379.4 units. And we end up with a difference of 1,103.6. Remember, the only way we can get incremental units is by looking at the total time after minus the total time before. Okay? And then finally, the time taken for the 100th unit. We said 100 units takes 2483 hours. The time taken for 99 units is 2461.9. And that means that the time taken by that 100 unit is going to be 21.1. Now this is the value that we've got to be careful of. Do you remember I said we may have rounding errors? You see, if we've established the time taken for steady state production, we may wish to multiply the value we've just calculated here by many hundreds of units. And if this value is not sufficiently accurate, then we will get a wildly different answer. So I hope I've shown you here how you can quite easily deal with learning curve. But remember, it's always the same approach. The approach is, let's get the learning curve bits out of the question first of all, and then interpret the incremental analysis afterwards. Don't do it together, because if you do it together, you'll make a mistake. Before we leave learning curve, I suppose we have to briefly discuss it. So what I've got here are the assumptions. Now, the reason why I'm interested in learning curve assumptions is because I believe a lot of them don't really hold true anymore. Because the learning curve was observed, well, one of the best examples of learning curve tended to arise during the Second World War, when most of these assumptions tended to hold true. So what we have is, first of all, a standardized product. A product that is not going to change. Of course, every time a product changes, the learning effect will stop and start again. So, do we have standardized products nowadays? Well, in some circumstances, yes, we do. But in many circumstances, products are continuously evolving. Secondly, little or no breaks in production. Does that necessarily hold true today? It's possible that a lot of products are produced in a staccato effect. You know, they're produced to order. And from that perspective, there may be breaks in production on a regular basis. Little or no labour turnover. If you have high labour turnover, then you're not going to get the learning effect, because all of that learning is going to walk out of the door. The operation has to be complex, If it's a simple operation, it doesn't require learning. And maybe most critical of all, the process is labour intensive. What I mean by that is that the labour determines the speed of the process, not a machine. Is that the case nowadays? Well, the answer is, again, it may be, but I think it's less likely to be the case. Most processes now are dictated by machine speed and not labour. So to summarise, learning curve is a popular question, and the interesting thing about learning curve is that it may be used in any part of the syllabus. It could be used as part of decision making, it could be used to establish standards for variance analysis, it could be used absolutely anywhere. It has been popular in the past, and I would expect it to continue to be popular.